Next is the conservation of kinetic energy and the potential energy. So now that we know that there is an interchange between the GPE and the KE, so we know that the loss in the gravitational potential energy is equal to the gain in the kinetic energy. This can be analyzed by analyzing the pendulum question. So the pendulum shows how at a specific position when the bob was lifted up with like against the gravity with a specific height, the bob was at rest at first and it had only GPE stored in it. Now the moment we will release it, all this GPE will be converted to KE. So in the process, like in this phase, the bob will have some GPE and KE, and they're usually equal to each other in such case. Okay, and like in this specific case, it's like if you have two bar graph, okay, that shows, if this one shows the KE and this one shows the GPE, then in the first case, in the first one, all the energy was GPE and we had nothing for KE. Then in this phase, second phase, it's like now we have GPE and KE, but the GPE, if you compare it to the GPE from the beginning, it's less. So it's like this GPE was divided between the two type of force, the energy. Then at the lowest position, all the energy will be now KE, and there would be nothing for GPE. Then once again, it will be GPE and KE as the bob is now being raised again until it will be back again to 0 GPE and all is 0 KE and all is GPE. Okay, so it's like it's the same amount of force, but it's being distributed over both type of energies. Okay, now in the first example we have a ball that is lifted it has a mass of 5 kg and it's lifted 2 meters above the ground. Then it was released. First question is calculate the GPE. Direct application to the formula. GPE is equal to mgh 5 times 10 times 2. Everything is given in the SI units, so it will be 100 joules. Question B, what is the kinetic energy at B just before touching the ground? So just before touching the ground, we said that all the GPE that was stored in the ball will be entirely converted to KE just few seconds before touching the ground. So in such case, we can say that GPE is equal to KE. So GPE, all this energy will be converted to the store of KE. So what is the velocity of B? Now that we have the KE and we have the mass, then you can apply the rule. That's the triangle. You can apply the rule saying KE is half mass velocity squared. So let's get the velocity. Velocity squared is KE over half times mass. By doing a direct application, do not forget to square root the answer. You will get 6.3 meters per second. Last question is, what do you think happens to the energy when the sphere touched the ground? So when it touched the ground, the kinetic energy will be converted into heat and sound. And this is the lost energy, the energy that is lost. Okay? Now this is slightly harder, or it's like the same type of questions. Find the kinetic energy of a boulder that has a mass of 4 kg and is rolling down over a cliff and it reaches the beach below with a velocity of 20 meters per second. So once again, we have the velocity, we have the mass, and it's in motion, so we're getting kinetic energy. It's going to be half mass velocity squared, do not forget the squared, and it will be 800 joules. What do you think the PE, the potential energy of the boulder, when it was still up at the top of the cliff? Since the energy while it was falling down was 800 joules, then this must be the energy that was stored in the boulder. So what we can say is that all the energy that is now converted into kinetic energy and that we got was originally stored in the body as a potential energy at the top of the cliff. Now find the height. Applying the rule, once again, we have the triangle. GPE is mgh. So we want to get h is GPE over m times g. And so applying the rule, we will get what? Oh, that's the triangle. It's already there. It's 20 meters. Okay? Now this is slightly harder type of question. Galileo drops a stone from the Leaning Tower of Pisa, which is 45 meters high. At what speed does the stone hit the ground? So the only thing given in this question was the height, nothing else. And we want to get the speed from that. So most students told me, how is that even possible? We only have the height. It's true, but we also know something really important, that is the energy conservation. We know that GPE and KE are equal to each other. We know that the loss in GPE is gonna be equal to the gain in KE. So just state the formula. What do you know about GPE? GPE is what? GPE is mgh. And what do you know about KE? KE is half mass velocity squared. Okay, write this down and you will see that in both sides the mass of the body appears. So the mass of the body, and since we're dealing with the same body, can be cancelled out. And so this is the trick here in such case, that even if you only have the height given, you don't need the mass, because the mass will be cancelled out. So the subject that we are looking for is the velocity. So rearrange everything. You will take this to the other side. And so we will get what? So it's half times mass times velocity squared. I'll show you the calculation. So it's 2 times g times h is equal to velocity squared. So 2 times 10 times 45, that's the velocity squared. 900 is the velocity squared. So v is the square root of 900, that's 30 meters per second. Last question. What happens to the energy as the stone hits the ground? Once again, it will be converted to thermal and heat, so heat and sound. And that's the type of question that are considered slightly higher question than the normal one.